Hi, welcome. We have been discussing about how to deal with sensor data analysis. I already handled a couple of sessions as how to get the data from the sensors through a microcontroller. In this case, I'm using Arduino. So in my previous video lectures, I've shown you how to get the data from Arduino to the computer. I mean, I've shown you how to establish how to construct simple circuits and read the data from the sensor to the Arduino, and from there throwing the data to the serial monitor, and from there getting the data to the Python serial. So this is a simple code that we use in order to get the data from the serial monitor to the Python editor. You can see that the simulated data happening in the computer. Actually, I'm not using an Arduino in this case, but I've been simulating this data through Linux by writing a script in Linux shell. You have a lot of content online as how to simulate the data from in the Linux shell, and through redirect the data to a particular communication port of your interest, and from there we can read the data to the Python editor. So here I have a Python editor where you can see that I am reading the data from this particular communication port. In my earlier videos you should have seen something like TTY ACM0, but here you can see my port name is a bit different. This time this is a port which I used to simulate the sensor data, and from there I am trying to read that data into the Python another editor. Okay, this is both of them are Python editors. So one editor I am using to read the data and another editor to display the data. But now that is okay, so anybody of you can do all this work. But once you get this data, what you are going to do, that is the most important. Since I am a data analyst, so my interest is always to compute a couple of statistics, and I will try to understand the behavior of that particular object. In this case, the object is the sensor. The sensor is reading the data from the environment. Again, in this case, we are using a photo sensor whose behavior is tend to differ based on the light that present or falling upon this sensor. So you just have to imagine that this data is getting simulated. We are getting this data from the photo sensor. So now, to understand the behavior as a statistician, my approach is to best compute a couple of statistics, most preferably number one, mean, arithmetic mean, and number two, standard deviation. So once we compute these two statistics, I think we can simply try to go ahead in order to understand whether the behavior of the sensor is normal or abnormal, something like that. We have a hell lot of theory to deal with this particular aspect of statistics. First, let me describe you how to compute the mean and standard deviation. So my approach is very simple. I think you need to have little knowledge about this statistics. In statistics, normally it so happens that the arithmetic mean actually expressed in terms of a ratio of sum of the data points over the number of data points. So I can write that as like this. See, the arithmetic mean AM can be the sum of given some random variable x. Okay, I'm sorry, my scribble is not good. So some sort of values, so this is just an arbitrary values, don't worry. So these are the values that are streaming from the sensor through Arduino. So the arithmetic mean is always going to be the ratio of the sum of ratio of the sum of x over the number of data points in x. So that's all. That's very simple. So in some statistics we also find a formula a little bit different, where people try to subtract 1 from the total number of data points in order to keep the arithmetic average as an unbiased estimate of. But anyway, that's a bit that is for people who are very much conservative, or maybe some sort of old style people, or maybe our grandpa times. But we need not worry. So let us put our statistics very simple. So I'm just going to write some code in Python, because Python is a wonderful programming language where we can simply write anything and do anything. So computing the sum of the data points and also finding the number of the data points is not that difficult in Python. So I'm just going to write a small code. Whenever we do some calculations, better to keep them above the loop. So here I'm going to create a small function, and my function, the way we create the function is through a command called def. So I'm going to define a function, and I'm going to give some name to my function. In this case I call the function as my mean, because the mean already might be there. I don't like to disturb that internal, the comments, so better I keep my own name so that my function will be different from the rest of the functions. So my mean, so first thing is the numerator I call num, and this is going to be, I have to put some data. So this is input data, and sum of data dat, and the denominator den, I simply call it den to keep it short. I don't have any other idea inside. Just my idea is to keep the names as short as possible. And we have a beautiful function called len to count the data points in the data dat. And now the mean, I simply keep it as m is going to be the ratio of num by den. And finally I return this m, so that my function will return m, which is actually the expression for the mean to the data. So as you know that the data is already streaming, so I'm going to create one more print statement and use the mean of the mean is, that's okay, let us not tweak too much, mean is, and here I think I have to keep my mean. I use my function. So what is the data here? Y. So let's say, I don't know, sometimes we may not. Oh my god, great, isn't it? So we have the data, streaming data, and just below that we have the mean is, something like that. So for every iteration we have a value that is getting printed. I'll just tell you, this is only the very shortest way of finding this statistic, but we can do a hell lot of analysis based on this particular information, in this case, which is mean. We can use this mean to plot the data, and also to further we can also use this mean for further calculations to understand the behavior of the. Now I'm going to show you how to write the function to standard deviation. So this time definition, my standard deviation dat some input. We are going to, the input which we are going to supply to this function is going to be dat. Okay, and the same all this, because the standard deviation need to have mean. So we are going to, I just push down this return. We'll decide what need to be written after a couple of minutes, after we finish all the calculations. So here first we need to go for the sum of the squared deviations. I'll let you know what is the standard deviation is going to be like this. The standard deviation is going to be the average value of sum of the squared deviations, which means the sum of the squared deviations are going to be like this, like the independent value minus mean whole square and sum of the deviations. This is the deviation, squared deviation, sum of the square deviations, which means we are finding the deviation, we square it, and finally we sum it. So that is sum of the square deviations, which we will use. And finally we find the averages, none other than to find the average we just have to divide this SSD by the number of data elements in X. That's all. So this is the average of the sum of the square deviations. And this is actually variance. Okay, I'm sorry, this is not standard deviation. And to find the standard deviation, we have to take the square root of variance. So this is how we need to find the standard deviation. So now let's go back and try to do some calculations. So some of the squared deviations, I think we need to, since we have the array here, the y is an array, so certainly we need to have a for loop for I in dat. Some of the squared deviations is going to be, let me put it like this, I minus mean to the power of 2. That's all, I think. Or I think we can also use it, I think we need not put for loop here, we can use for all for I in dat. So I think that can do well. Now where is going to be SSD divided by length of dat. So that's, so now standard deviation is going to be var to the power of 0.5, so which is actually the square root of. Now let us return standard deviation. So let me go back. Fantastic. I think we have to go down and say whether this function works or not. For first, let's go for, okay, mean and standard deviation, let's put it together. The standard deviation is my std y and new line. I think we may not, it doesn't matter. Okay, but better to keep new line. Oh my god, I'm extremely sorry, we forgot, actually we have some here, this, I think we forgot this particular, we forgot to sum of the values. So let me correct my sum of the values. And what else? I think this time everything must be, I think here better to, okay, no need of new line. It will say, let us do this. Oh yeah, so we are getting this. So every time, let me stop this. See, we have the raw sensor data streaming to the Python and the mean value along with its standard deviation. So this way, now what we need to do, anyhow, having computed this statistics, we can now plot this data and see whether it is normally distributed or not, and we can make use of this mean and standard deviation in order to find the confidence intervals, and that information in turn can be used to further simulate, maybe we can use it for the machine learning. So next time when I replace my sensor, so the machine must be able to tell me that the replaced sensor is exactly the sensor that we are interested in or anything else. So that way we can proceed ahead with statistics. Anyway, so if you like my video, just press thumbs up, stay tuned and watch for further content. Thank you.